Hey guys, I'm Jay. Today is my LeetCode review vlog on the 90-second problem, Reverse Linked List 2nd edition. We are given the height of a singly linked list and two integers left and right, where left is less than or equal to right. We have to reverse the nodes of a list from position left to position right and return the reversed list. Let's see example 1 here to understand it easily. We got the original linked list 1, 2, 3, 4, 5, and the left is 2 and right is 4. So we have to reverse the sub list, and the final result is 1, 4, 3, 2, and 5. Then let's get started with our introduction to solve the problem. So the keyword is rearrange the pointers. Rearrange the pointers by 3 detailed steps. The first step, we'll traverse the list to find the starting point of the segment to be reversed. Then we'll reverse the segment and we'll reconnect the reverse segment with the rest of the list until all the nodes in the sublist being processed. Next, let's get started with our code to solve the problem. So the very first step, we have to handle 2 edge cases. If height equals null or left equals right. For these 2 cases, the list is empty or left equals right. There's no need to reverse the list, so we just return the original height. And the second step, we'll create several variables to help us solve the problem. So for the very second step, we'll create a dummy node to help us simplify the reverse process at the head of the list. Let's say the code is list node dummy equals new list node. Let's say the value could start it at 0. For example, the head node could also be reversed, so a dummy node can help us always find the final correct head node. Next, we'll make the dummy.next pointer points to the head. Dummy.next equals head. Then we also have to create another pointer called previous pointer. Help us solve the problem. Let's say list node previous equals started at dummy. Then we have to move the previous node to the node before the position left. And the code is for int I starting at 1 and I is less than left and increment I after each iteration. And inside it, we just move the previous node 1 step forward after each iteration. Previous node equals previous node dot next. And out of the for loop, the final previous node would be in front of the sublist. So we have to create a start point points to the first node in the sublist. Let's say list node, let's call it start, equals previous node dot next. Because we have to use the start node to reverse the sublist from left pointer from the left position to the right position. And we'll set the start pointer to the first node of the sublist. And this needs to be reversed. And we have to notice the start nodes won't change during the whole iteration process. And we also have to create a then pointer, and and the initialized value should be start.next. This is because the then node is a node that will be moved to the front of the sublist during each iteration. So we have to remember the then node will change during each iteration, but the start node won't change. Next, we'll create a for loop to reverse the sublist by rearranging the pointers. Let's say for int I started at 0 and I should be left than right minus left, and increment I after each iteration. And inside the for loop, the very first state, we have to connect the start node to the next node of the then node. And code is start.next equals then.next. Next, we'll move the then node to the front of the sublist, which is previous next equals then. Oops, it is not correct. In the second step, we'll move the then node to the front of the sublist. So the code is then.next equals previous node.next. And for the third step, we'll connect the previous node to the then node. And the code is previous.next equals then node. And for the final step, we have to update the then node to the next node to be reversed in the next iteration. Then equals start.next. And we have to repeat the 4 steps for each subsequent node in this sublist until the entire segment is reversed. And out of the for loop, we just return dummy.next, which is the final correct head node. Then let's check the correctness and analyze the time and space complexity. Yes, our code got accepted. So the time complexity, it is big O of n. This is because we traversed each node in this list for only one time. And the space complexity, it is big O of 1. This is because we just used several pointers and variables, and they are not without any additional data structures that grow with input size. And thank you guys for watching. This is the end of my LeetCode review vlog on the reverse linked list 2nd edition. And I highly recommend you guys to visit my online GitHub page here, which contains 150 LeetCode problem solving nodes. Let's say the reverse linked list 2nd edition problem here. You can see the problem description, intuition, Java code with explanation, and walkthrough graph of solving problem, and the final time and space complexity analysis. You can also visit my GitHub repository here, which contains all the codes and nodes to build the online GitHub page here. And thank you guys for watching. I'll put those 2 links on my YouTube description below. And I'll see you next time. Bye bye.